All right. Hello and welcome.
Hello and welcome.
Thank you for joining us here
Thank you for
today.
joining
My
us
name
here
is
today.
Dmitry
My name
Baev.
is
I'm
Dmitry.
the Vice President of Solution Engineering at H2O.ai. And today we're going to be talking about deploying distributed AI and machine learning in financial services. Some key points that folks to walk away with. We're going to start by talking about building distributed machine learning models. We'll then touch on different ways of automating the machine learning lifecycle. Obviously, we have to keep in mind, how do we ensure interpretable machine learning models, especially for regulated industries such as financial services. And finally, we'll talk about accelerating model deployment by closing the gap between data science and DevOps. So in many engagements with our financial customers who are looking at AI transformation, it really comes down to three things. It's data, it's AI, the technology, and it's people as their skill sets. And it's all data. Now, luckily, many financial organizations have vast data reserves. And for the last maybe 6 to 8 years, they have embraced different data lake projects. So looking at opportunities to bring data together, to break down data silos, and to pool information or data from wealth management, consumer banking, financial trading applications, cybersecurity, AML, and so on and so forth, to really bring all these data assets together to form the enterprise data lake. And as you can see here in this data science hierarchy of needs, you will find that in order for you to have an effective AI and ML strategy, it does require having a very solid data foundation. And as such, the bottom layers of this pyramid all have to do with your data management aspects within the enterprise data lake. So it's collection of the data, it's the moving, the storage, exploration, and transformation. And then as you get higher up the layers of this pyramid, you then start looking at various data science aspects, such as data aggregation, labeling, various learning optimization algorithms, and finally coming up to machine learning and AI. And that's really where H2O.ai as a company is really focused on. So let's take a few minutes to really talk about H2O Enterprise. It's composed of these 5 pieces. We start with H2O Core, which is a collection of distributed machine learning algorithms which have been designed and built from scratch to be able to process high volumes of data from gigabytes to terabytes to petabytes by leveraging scale-out distributed architectures such as Hadoop, Spark, and Kubernetes. There is a special project called Spark and Water that allows combination of the Spark ecosystem with H2O distributed machine learning. We then move into automated machine learning using H2O driverless AI, and we'll talk a lot more about that in detail. And finally, we look at H2OQ, which is an AI platform for business users that really takes us from the algorithms, which is the focus of H2O Core, ML models, which is the focus of H2O driverless AI, into now easily composable AI applications that can be used to democratize AI across the enterprise. The underpinning of all that is the Model Ops, which is H2O ML Ops platform that helps not only with model deployment and monitoring, but also making sure that you've got AI management capabilities, whether you want to deploy your machine learning capabilities on-prem or in the cloud. So we start with H2O Core, which is a collection of distributed machine learning algorithms, whether these are generalized linear models as GLMs, different boosting machines, GBMs, XGBoost, various deep learning algorithms. All of these have been really able to take advantage of the distributed nature of the infrastructure that is available. And in financial services, again, many have embraced Hadoop and Spark ecosystems. Many are now moving into Kubernetes by deploying those platforms both on-prem and in the cloud. So if you take a closer look at how H2O facilitates distributed machine learning at scale, we start on the left-hand side with a data scientist who typically works within their favorite language and IDE. So it can be Python and Jupyter, it can be R and RStudio. So this is where they write their code. And they have a unified framework, how they can leverage all of the H2O algorithms, whether these are supervised, unsupervised, deep learning, or even automated machine learning algos that come packaged with the H2O framework. And the neat thing is that no matter what problem you're trying to solve or what language you're coding, whether it's Python or R, the execution that happens on the right-hand side is fully optimized by the H2O framework and are underpinnings of the H2O algorithm that allow you for that seamless deployment and seamless integration across Hadoop, Spark, Kubernetes environments, whether you're running on-prem or in the cloud. Now, if we take a closer look of what actually happens when a data scientist tries to program using H2O and trying to build distributed machine learning pipeline, we start again on the left-hand side by loading a data set from maybe it's HDFS if you live in the Hadoop world, maybe it's S3 or other forms of object store, could be just a SQL connection to an RDBMS. So you start by loading the data into the H2O cluster. By the virtue of the cluster and the mechanism of H2O, the data gets distributed in memory. It gets chunked up across the working nodes that are available for your machine learning job. We use lossless compression that allows us to do to optimize memory consumption and to ensure that the data is properly compressed as we distribute it across the multiple working nodes. You then embrace exploratory data analysis. You go through feature engineering, feature selection, apply a variety of supervised and unsupervised modeling techniques. And finally, you end up with a number of different models that you will then use an iterative approach of actually evaluating the model performance metrics, maybe fine-tuning the hyperparameters, and repeating many of these steps over and over again. As we all know, it's a highly iterative process. At the end of your machine learning job, which may span multiple iterations, the data scientist would typically actually preserve the model as a Mojo, which stands for H2O Model Object Optimized. So it is a piece of the deployable code, which is binary in its nature, has really no dependencies on the algorithms that you've used. We'll talk about Mojo runtime in more details, but essentially the Mojo object is only coupled to the Mojo runtime, but other than that, it can be deployed in a variety of environments from Java, C, C++, Python, any language bindings, and have no dependency on the Hadoop, Spark, Kubernetes, or the H2O frameworks that were used to train your model. So now let's take a simple example of how you would actually go through this model training and deployment in the Spark ecosystem. So we start with model building. In this case, we have our data source, which could be a relational database or some form of a data source where Spark can read data from. We all know Spark is a very popular distributed data processing framework that allows us to do data engineering at scale. The data gets loaded into Spark data frames. And then once you've done with your data munging or data engineering part using Spark, you can now tap into the power of H2O. And this is where sparkling water comes very handy, because think of this as a wrapper that allows you to natively go from a Spark data frame to an H2O data frame. Both happen in memory, so there's no read or write from disk, very highly performant. Essentially, all of your data, the way it was already pre-processed in a Spark data frame, gets transferred into H2O frame, and now you can apply any of the H2O algorithms, whether this a GBM, an XGBoost, K-mean, supervised, unsupervised, right? You have the full capabilities of the H2O3 library to your disposal. And once the H2O training job is done and you're happy with the results, you will again preserve the model as a binary object, which is called the Mojo, and its only dependency is the Mojo runtime. So that is the model building phase. We now look at the model scoring phase, which in this case, let's assume that we have a real-time data stream with a Spark streaming application, which allows you to now call, maybe you receive an event, maybe you want to parse out some details about that event, and at some point within that single Spark pipeline, you want to make a call to the H2O Mojo object in order to be able to get a scoring prediction. And now that scoring prediction can be used further in your application or maybe inform a business process or a business analyst of some decision. Now, that is a very simple scenario. And as we start looking at the enterprise machine, you'll notice that there are many steps. Many of these steps are highly iterative in nature. And not only that, but it also encompasses many different personas. So you're going to be working between a business analyst, a data engineer, the data scientist, DevOps engineer, and there could be other folks involved as well. Now, as we look at the science portion of this life cycle, you will then notice that for every phase of the data science that the data scientist is involved, whether it's feature engineering, model building, or model deployment, it gets even deeper and gets even more complicated because the data scientist needs to be very well versed in different types of encoding schemes, target encoding, for instance, how to generate the features, how to do feature selection, trying different algorithms, understanding the parameters, the tuning parameters of each algorithm independently. In some cases, building model ensembles that combines the power of different predictors into some sort of blended ensemble. Generating the final pipeline, which always involves converting from R and Python, which is the data science-centric language, to a production-centric language, which in many cases is Java or C, C++, and then really having to think about model explainability and model documentation. These steps are extremely time-consuming, they're very error-prone, and they require high degree of skill set, both from the data scientist and from the production machine learning engineer, which really means that this highly iterative process can take from weeks to months to develop a single production-ready model. Combining all these things together, we find ourselves along these lines where this is an enterprise machine learning workflow and really highlights the challenges, right? So to a fair bit of detail, the challenges that you have to go through in order for you to ensure that not only you're able to solve your business problem, but you're also able to develop a precise, highly performant, and sometimes highly sophisticated machine learning model, but yet be able to explain that model, ensure that the model is well documented, and also make sure that there's a proper handoff between the data scientist and the machine learning engineer who puts those models into production in order for applications or business users to be able to take advantage of those models to make business decisions. This is where we enter the world of AutoML. And AutoML comes in phases, or what we call Gen 1. The Gen 1 AutoML is part of what we call H2O AutoML, and it's really focusing on automatic model selection, hyperparameter tuning, performing various grid searching strategies, and then outputting a model leaderboard that the data scientists can explore by hand to understand which model is the best performer. Unfortunately, the first generation does not necessarily focus on advanced feature engineering, automatic data transformations, or anything around model documentation and interpretability. So this is where the second generation with H2O driverless AI is really focusing on. The way it's delivered is through what we call recipes. So not only driverless AI focuses on different machine learning tasks such as time series, NLP, computer vision, tabular data, but it also gives you the ability to extend those by bringing your own custom recipe, and it automates the process of doing feature engineering, data transformation, ensuring that the results are highly interpretable and explainable, and always generating that final model pipeline that can be used for deployment into your production environments. Moving into the third generation, the idea here is how do we now take the learnings from the first gen, which is around the algos, the second gen, which is around models, and how do we now really incorporate this in a way that can deliver applications to the business users such that they may not be versed in the algos or the models, but they really want to ensure that the AI applications are geared towards solving their vertical challenges or specific use cases. So with that in mind, let's take another look at how this would leverage distributed machine learning using H2O AutoML. Or now, rather than manual steps, that's what AutoML can deliver for you. Okay, looks like we hit a pause there. Let's overlay and have a look at how AutoML solves those challenges. So from a data scientist perspective, you would be responsible for loading the training and the test data set into H2O, defining the response and the predictor variable, and then letting AutoML run through a permutation of different model building techniques, optimizing hyperparameters, doing grid search to really optimize your models. At the end of the AutoML run, where you would specify some parameters around the stopping criteria to ensure that that the search space isn't unbound. You want your AutoML to maybe run for several hours, could be several days, depending on the size of the data and the complexity of your models. But eventually, you will come back and you will have to introspect the leaderboard, explore different ensemble compositions for models that are more complicated, where multiple models are being assembled together, and finally determine which is the leader model that you now want to export into this Mojo object that we talked before. So again, this exact same output, but a lot of the manual steps now have been optimized by the virtue of AutoML. What we haven't covered here, and that's where driverless AI with the Gen 2 is the feature engineering. So driverless AI now takes the AutoML to the next stage by allowing you to incorporate advanced feature engineering through the genetic evolutionary algorithm that looks at feature that employs essentially a genetic approach to feature evolution, and it goes through multiple iterations of building models, fitting them on a set of features, determining just provide a lift, and those features essentially make their way to the next stage, to the next iteration of the algorithm, where a new set of models and a new set of parameters is being tuned. And those features that have not produced any kind of a lift to the overall model, they will eventually die off and they will get discarded. And this process repeats itself many times over. It could take 40, 50 iterations with hundreds of models and maybe thousands of features and parameters that are being explored. And at the end of the run, what you end up with is a scoring pipeline that essentially encompasses every step that has been taken throughout the training of this model. And you end up with a single scoring pipeline that can now be deployed into production. And not only it encompasses the model itself, but it also takes into account all the feature engineering, the model transformations, the data transformations that had to be applied as we have gone through this feature engineering process. And everything is encapsulated into this single scoring pipeline artifact that is available for you for deployment. The key part about driverless AI, and this is where we get a lot of questions from our financial services customers, is, well, how do I make sure that I have full visibility and full control over what's actually happening inside of your platform? So driverless AI is powered by the latest open source innovations, so from LightGBM, XGBoost, TensorFlow, H2O, and so on and so forth. But it also allows you to extend the power of what's available to you from within this AutoML platform by letting you bring your own code for your own transformations, your own algorithms, and your own scores that are really focused on solving your particular domain or your specific use case. And this is where, as an advanced and an expert data scientist, you can apply your data science skill set to write Python code, which will be used for specific transformers or specific algos, or maybe some scores that have business impact and business metrics in mind as you're trying to pursue a specific use case. Now, putting it all together, the way a single experiment using driverless AI would look like is you start by sourcing your data from a variety of data sources. Again, you have a modern data set with the X predictors and the Y target variable. You look at, you can start by looking at your data set by using automatic visualization to get a better understanding from a data science perspective, if the shape of the data, if there are any outliers or missing values. You then go through your own recipe customizations if you want to bring your own Python code that deals with scores, algos, or transformations. All of that gets amalgamated into what we call the feature brain, right, or the automated machine learning algorithm that driverless AI encompasses as it goes through the various phases of the feature engineering, algorithm selection, and model tuning. And at the end of the experiment run, what you end up with is this automatic scoring pipeline, which can be easily deployed, and we'll talk about various deployment patterns, but also keeping in mind that machine learning interpretability and model documentation is extremely important in order for you to trust an AI to really ensure that you can adhere to a lot of the specifically highly regulatory use cases specifically in financial services industry, and that's where we employ some of the latest techniques when it comes to machine learning interpretability, such as Shapley, Lime, Keyline, PDP, ICE, and many other techniques that focus on model interpretability, both for the actual model as well as any surrogate models that we build, as we go through this interpretability process. As well as every model that gets produced by driverless AI is accompanied with a full documentation, which could be 30, 40, 50 page document. And that document is really key both for collaboration between teams of data scientists to get a better sense of how the model was constructed, the various steps, the various transformations that were taken, model performance metrics, but it's also a key document that needs to be passed to the model validation and model risk management teams in order for them to be able to be comfortable that these models can be deployed into production, that we're not actually creating any adverse impact, for instance, any bias, or that the model can cause risk or harm to the face of your business. And by the way, the model documentation alone could shave weeks, if not months, off the plate of a data scientist, because these documentations are very tedious, and that's where our team has worked very closely with our financial services customers to really customize the look and feel of these templates to the requirements of model validation teams. Now, as we talked about, one of the key benefits of using H2O, not only from a training, from the distributed training perspective, but also when it comes to model deployment. So the Mojo, as we talked about, is a key artifact that essentially encapsulates the model itself, the feature engineering. It's a binary object that has its own dependency, is the Mojo runtime, and it's completely algorithm independent. So whether you use XGBoost or LightGBM, TensorFlow, doesn't really matter. Once we have the Mojo object created, the Mojo runtime is the only dependency that you need, and it can run in any Java, C, C++, Python, R, any of the language bindings that are available, highly portable, highly flexible, that can really be deployed in a variety of environments. So if we look at how our financials typically go about deploying their models, again, you would start with a data scientist who's responsible for the model building on the left-hand side, whether they leverage H2O Core, sparkling water, or driverless AI, they will produce the Mojo object, which is that highly flexible, highly portable binary representation of the model. You take the model runtime that comes along with it, and now you have a choice of either deploying this onto H2O MLOps, which is a model deployment, model monitoring environment based on top of Kubernetes that provides you with model monitoring capabilities, alert dashboards, drift detection, champion, challenger, A/B testing, all the typical capabilities that mature data science teams would come to expect from their machine learning, from a deployment of machine learning models. But you can also easily deploy this into your own infrastructure, your own environment. And this is where Mojo, the flexibility of the Mojo deployment becomes so powerful, because not only you can deploy this into a variety of real-time streaming and batch environments, but we've also worked very closely with customers to ensure that we have designed best patterns, that we've designed deployments that allow you to, with a single click or with a single script, to deploy H2O models or H2O Mojos into AWS Lambda if you want to, for instance, serverless functions, relational databases, Hive UDFs, streaming applications such as Apache Kafka, Spark Streaming, REST API integration, and many, many other types of deployment environments. By putting all of this together, you can now see that, again, coming back to the same picture that we saw before, with the machine learning workflow that is very intricate and has many different phases or stages, H2O AI platform allows you to really automate the majority of it, where there are different levels of automation, but at every step of the way, we ensure that the data scientist or the ML engineer is in full control, and hence we allow you see that the stages are color-coded into yellow, blue, and green to an extent that it's automate it, but you can customize it, you can control it, or you can extend it. I know we're coming up to the end of the talk, so just really quick about H2O. We are a company that was founded in 2012 with 250 experts around the world, and we pride ourselves working with over 20,000 organizations that have been using open source since the founding of the company in 2012. I'll take a pause here. All right, and now jumping off to the Q&A portion for the remaining 5 minutes that we have here. Let's have a look if we have any questions that came in. So, questions for the organizers. I see a lot of attendees. I don't see any. I don't see any questions in the chat. Yeah, I don't see any questions from the attendees. Again, thank you very much. If you have a chance, please download a trial copy of Driverless AI to put your hands on H2O automated machine learning, and we'll be happy to work with you if you have any further questions. Thank you very much and have a great day. Take care, everyone.